Hey, welcome back to the workshop. So here's a question. Does Minwax Wood Hardener actually harden wood? Well, it kind of does, and it kind of doesn't. It's complicated, but stick around and I'll show you what I mean. Okay, one of the first things that I want to know is what's left behind after the solvent evaporates out. I know that Minwax Wood Hardener is a form of plastic that is dissolved in a solvent. I want to know what the plastic is like after the solvent evaporates and just the plastic is left behind. I'm going to pour this out here and let the solvent evaporate out, and then we'll see what we get after that. Alright, so my little foil basket of wood hardener has been allowed to dry in a warm room for 24 hours. Let's see what's left behind. There isn't much here. Yes, I had hoped that I would have a layer of plastic I could peel away from this. But it's really thin and it's kind of sticky. It's almost like a glue or something. Alright, so it's kind of hard to see on here, but what's left behind after the solvent evaporates away from the wood hardener is this kind of rubbery, sticky, glue-like stuff. Now, I'm not entirely sure what this is. I think it's just some kind of incredibly soft plastic, but I don't know for sure. But what's important to note here is that when you put this on wood and let it dry, this is what gets left behind to stay in and strengthen your wood. And while it's kind of sticky and it's got some substance to it, you know, maybe it does provide your wood some sort of structural reinforcement under some circumstances, but what it's definitely not is it's not hard, it's not brittle. You know, it smushes rather than chips. So whatever the properties of this stuff are, one thing it's definitely not is it's not as hard as wood. So I don't see where putting this in my wood is going to make my wood any harder than it was to start with. So at first glance, it looks like the stuff that's left behind with cured Minwax Wood Hardener isn't actually all that hard. But is that the whole story? I don't know. Let's put it to the test. Alright, here's how this is going to work. We got a heavy piece of wood with a metal spike on one end. This is going to get dropped onto my wood from a constant height. And then we're going to use the hole depth gauge on the calipers to measure how deep of a dent we make with this spike. I'm going to compare it to dry untreated wood and wood with wood hardener on it, and we're going to see if the hardener makes any difference at all. Alright, I'm going to put 5 coats on here, which is maybe more than you would actually use if you were using this product in the home. But I want to make sure we get enough on here to say that we've done something. But let's test it and see what we get. I've got my piece of pine wood here. This side is dry and untreated. This side has been treated with 5 coats of Minwax Wood Hardener. I'm going to drop my spike block on it and see if there's any difference in the depth of the dent. In theory, the side with the wood hardener on it should have a shallower dent because it's been made harder. Will that happen? I don't know. Let's find out. Okay. Of course, Minwax Wood Hardener is meant to be used on dry rotted punky wood. Maybe using a hard pine board isn't that good of a test. So I'm also going to use balsa wood. This is as soft and you could almost call it punky as any new wood gets. I think this will be a good representative test. We can pretend that this is dry rotted wood. Balsa is certainly the softest wood that's available, and if wood hardener does any kind of hardening at all, you're going to see it hardening balsa wood. Okay, so how did we do? Let's look at the numbers. In this graph, we compare the impact depths between the dry, untreated pine wood, shown in green, and the wood treated with wood hardener, shown in blue. While the difference is slight, just a few thousandths, we do have a clear reduction in depth on the treated side, indicating that the wood hardener really does harden the wood to a measurable degree. But let's dig deeper. The actual physical difference between the treated and untreated measurements averages around 0.004 of an inch. That's not much. Out of a sample set of 10 impacts each, the dry untreated wood dented to an average depth of just under 18 thousandths of an inch, while the treated wood dented to a slightly lesser amount of just under 14 thousandths of an inch. The difference of the averages is just over 4 thousandths, which is tiny. But in percentages, this represents a percentage difference of 23.6%. If my numbers are correct, the treated board really is a little bit harder. Now, keep in mind that this isn't the most precise test in the world, and a 23% difference in depth isn't necessarily the same thing as a 23% increase in hardness, but it does indicate that some hardening has occurred. Now, how about the balsa wood? The results on the balsa wood are really weird. By my measurements, the balsa treated with wood hardener is actually slightly softer than the dry balsa alone. I have no idea what's going on here, but that's what the data shows. The dry, untreated balsa wood dented to an average depth of 227 thousandths of an inch, or just under a quarter inch, if that's easier to think about. On the other hand, the balsa wood treated with wood hardener dented even deeper, to an average depth of just over 238 thousandths. The difference of the averages is just over 11 thousandths of an inch, indicating the wood has gotten an average 4.93% softer after the wood hardener was applied. This is an unexpected and weird result for sure, and I may continue to experiment with balsa in the future to see if I can figure out what's really going on here. But again, keep in mind that this isn't the most precise experiment in the world, and with such small differences between the treated and untreated pieces of wood, much of this difference could be unavoidable mechanical measurement error. Also, keep in mind that wood is a complex structure at the cellular level, much less at the molecular level. It's possible that something in this wood hardener reacts negatively with the structure of balsa wood in a way that it doesn't react with other types of wood. I just don't know. So there you have it. Does Minwax Wood Hardener actually harden wood? My evidence suggests that, at least for pine wood, yeah, it does a little bit, but keep in mind, this isn't a miracle product. I think if I had some wood that really needed structural reinforcement, I would look into some sort of epoxy or resin or something. I probably wouldn't use this unless my reinforcement needs were pretty light. That being said, for other types of wood that aren't pine, I don't know, my result with balsa was really weird, and so keep that in mind. And as far as this experiment goes, I think I learned a lot, but there's definitely always more to learn, more experiments to come. Either way, I hope you learned something too, And I hope you found that interesting, and I'll be right back here in the workshop with another video just as soon as I can. See you then.